Hi everyone, we are going to solve today problem 3347, which is a hard integrity problem, and it is maximum frequency of an element after performing operations 2. So its first part is already solved. Simple. Let me explain you questions quickly. So we have an array nums. We can apply any operations number of times, and what we can do in each operation, select any index that has not been chosen before, and at element added index can be added anything in the range minus k to k. So we have to find the maximum possible frequency after applying the operations. Only difference with part 1 is the constant. I will suggest you to check my code and my solution for the part 1 in the last video. Then you will understand it in a better way. So let me show you my solution for the first part. What I have done, I have iterated over all the numbers, over all the candidates for the mode after applying the operations. I was checking if it is possible, and anything is possible if it is in the range of smallest number to largest number. So here, iterating over all the elements from smallest to largest is not possible because it may go up to 10 to the power 9 and it will give a TLE. So optimize it. What we have done a minor change. The solution is same. In unordered map M, we are storing the frequency of all. First of all, we have sorted the set, and we have storing the last index as 0. And in unordered set, we are storing map. In unordered map, we are storing the frequency of our any particular number. So it is sorted. So once we are checking every number, we are iterating over the nums and checking every number if it is not same. So we have found like different numbers. So for the last number, frequency is this one. It is gained without applying any num operations. So we can already add 0 to all the number, and it is already an answer, maximum answer. Now what we are doing here different is that instead of applying over all the candidate, considering everything as a candidate, we are limiting our solution to mode is storing our all the possible candidates for the after applying the operation. So how we are optimizing it? See, first of all, that particular number can be a candidate for the max frequency. Apart from that, what can be a possible? We are iterating over all the numbers. Now what we are doing with the particular candidate, we are checking its upper bound and lower bound. Now suppose if a particular number we are having, we are checking upper bound and lower bound of x minus k and x plus k for a candidate minus k and plus k. Now suppose we are iterating at nums of last index. If it is in the range of smallest to largest element, then we are storing nums of last index minus k and plus k as a candidate, because these are the boundary elements. Let me show you with an example, then it will be I can explain in a better way. Suppose we have 2, 5, 7, 9, and we have k is equal to 4 and we are at 7. So we are storing in our possible candidate as 3, and we are not checking for 4. Why we are not checking for 4? Let me explain you. If we are checking, what we were doing, we were doing upper bound and lower bound. For 3, upper bound for candidate 3, if we are taking x plus k, so it is going to be 7, and upper bound for 7 is going to be 9. Now we are taking 4. For 4 also, 4 plus 4 is 8. So for this also, upper bound is going to be 9. It is already the same. So index is same. So why we need to repeat operations? Now we will say that yeah, it is possible that lower bound may change. Yes, it may change. If the lower bound changes for any particular number, so we are also storing nums plus k. We are considered 7 as for is 3. Now suppose 3 is a candidate, we will say lower bound may change. So what we were doing is that for all the numbers, we are all in the candidate, we are also storing plus 4. So the lower bound changes, 2 plus 4 is 6 and 5 plus 4 is 9. So in the candidate, we are also having 6 and 9. So if it is, suppose 3 and 4 would have been a possible, if we are storing 3, you will say that yeah, for there can be possible case for where for 4 the lower bound will change, but upper bound is same in this problem. So in that case, we are also storing the plus k for a particular number. So if the lower bound is changed, that is also considered as a candidate, and we will check for that answer for that also. So it is in this way we are optimizing that we are not checking every element, but all the possible candidates, so that for which the upper bound and lower bound index is going to be same, and we are checking at that point where it may change, lower bound and upper bound may change, so that we do not have to check all the numbers in the range, in the mid range of that upper bound and lower bound will have the same aligned arrow and will give the same the value. And even these numbers are not and numbers which are in between, which are not present in mod, are also the numbers not present in the array. So in that way, it is not going to be answer which is going to exceed our best possible answer. So we are checking if our index, if our unique number, whatever we are finding, is in the range of smallest to largest element, we are inserting it, and then We are iterating over all the possible candidates. We are checking for the candidate x minus k. What is the first element? Basically, the first index which is which is greater than or equal to x minus k, and first index which is so the last index which is less than or equal to x plus k. For that, we are taking upper bound of x plus k and decreasing it. So in that way, we can tell that yeah, this is the range of number r minus l plus 1. It can be converted to x, and we are checking if num operations is sufficient to do this, and also if the number is already available in the nums. So we are considering that yeah, without even applying operations, that number is increasing our frequency, and thus the answer is maximum of all. So thank you.